Every farm has a graveyard, usually behind the barn, sometimes stacked against the tool shed wall, broken handles, bent frames, cracked welds. Almost everything in that pile failed at the same spot. Same joint, same junction between the handle and the head. That's not bad luck. That's a design decision. Every manufacturer knows exactly where their tool starts to fail. Some engineered around it, most didn't bother. Every field repair starts with one question. Do you have the right wrench? Not approximately right, actually right. Old American Iron, a Farmel, a John Deere from before the 1980s, runs on SAE. Import tractors and most modern equipment run metric. A combination wrench set covering both isn't cautious preparation. It's the operational reality of any farm with mixed equipment. The problem it creates is a different one. 40 wrenches in a tray. And in the dark, under pressure, you're still looking for the right 10 millimeters while the engine idles. Tecton and Gear Wrench own this category. Both use chrome vanadium steel, both have lifetime warranties, and at similar price points, they look nearly identical in the store. In side-by-side torque comparisons on grade 5 fasteners, Gear Wrench held longer before slipping, thinner profile, tighter tolerances at the box end. The warranty split matters practically. Tecton replaces without a receipt. Gear Wrench requires proof of purchase. On a farm where 2019 receipts are filed somewhere between seed invoices and tire records, that's not a minor detail. The open jaw on any combination wrench is the weakest point, not because of brand, because of geometry. A corroded bolt that hasn't moved in 2 seasons will let the wrench slip before it gives. That's not bad steel, that's physics. A single solid 1/2 drive socket set outperforms 3 partial smaller sets on a working farm. Rusted hardware on implement hitches and mower decks needs real torque and real drive. Forcing a seized bolt with a 3/8 drive handle doesn't just fail. It rounds the socket profile. Cheap sets wear the contact geometry before the bolt moves, and a rounded bolt is now a different problem. A vice grip problem, a cold chisel problem, 40 minutes you didn't plan for. The breaker bar comes out rarely, but when it does, nothing replaces it. The standard field workaround is a cheater pipe, a length of steel slid over the ratchet handle for extra leverage. It works once and destroys the ratchet mechanism doing it. An 18-inch or 24-inch breaker bar on a 1/2 drive absorbs the same load without transferring it to a component that was never rated for it. The adjustable wrench, crescent or channel lock, doesn't replace the right wrench. The jaw gap grows with every use on worn hardware. That's not a flaw. That's how the mechanism works under load. On a gate fitting, a hose coupling, a trailer connection, it belongs. On a tractor bolt, it's how a tight fastener becomes a rounded one. In 2008, Newell Rubbermaid shut down a factory in DeWitt, Nebraska, where vice grip locking pliers had been made since 1924. Over 300 workers. The building is still there. The name transferred to China, and the tool kept showing up on store shelves, looking identical to what came before. Experienced mechanics noticed it fast. The adjustment screw, the mechanism that sets jaw tension and holds lock, started showing wear earlier in newer production runs. One of the first reviews after the move described a jaw cracking on first use, not first season. First use. The point isn't that the new vice grip is useless. It still outperforms most no-name alternatives. The point is that a farmer buying on brand trust is buying a different product under the same name, with the same expectations, and no way to know the standard changed. On a farm, vice grip locking pliers are emergency tools, holding a part in place during welding or cutting, standing in for a broken bolt stub, clamping a hose fitting that lost its clamp. The locking mechanism is the whole point. When that mechanism wears faster than expected, it doesn't announce itself. It fails mid-grip, under load. Channel lock, tongue, and groove pliers cost around $20 for a 10-inch pair. Knipex Cobra runs $60 to $70 for the same size. The price difference reflects one specific mechanical difference. Channel lock uses bidirectional teeth and holds by friction from jaw pressure. Knipex Cobra uses a unidirectional ratchet-style mechanism. The harder you pull, the tighter the grip locks. That distinction is invisible on most tasks. It becomes real on a hydraulic fitting under pressure or an iron pipe fitting that's corroded into the coupling. Channel lock can slip on a rig pull. Knipex can't by design. For a farmer who works with hydraulic lines regularly, that $40 difference is a single incident avoided. For everyone else, channel lock is more than adequate, and channel lock is made in the USA from carbon steel with laser-hardened teeth and a permalock joint that doesn't loosen over time. The multi-bit screwdriver, Milwaukee or Klein tools, is a daily carry tool, not a repair tool. The failure mode isn't the handle or the shaft, it's the bits. Control panels on tractor electrical sections, cover plates on implement housings, most of those screws are aluminum or plastic housed, and an overdriven or rusted fastener strips the bit face before it strips the screw. Once the bit face rounds out, the next use strips the fastener head. Milwaukee ships better grade bits than most, but they're still consumables, and the farmer who doesn't carry spares finds that out at the worst time. The digital multimeter closes this block. A Fluke 87 volts and a $40 X-Tech will both give you the same reading on a 12-volt battery. The gap between them isn't measurement accuracy on a small farm, it's durability after being dropped from a tractor step and resistance to moisture. For checking a solenoid, tracing a broken ground, testing continuity from the battery to the starter, X-Tech does that. The $200 price difference buys ruggedness, not function. But the tool that actually solves nothing on a small farm is a multimeter in the hands of someone who doesn't know the sequence. Battery voltage first, then ground connection, then solenoid, then wiring continuity. Without that order, neither brand gives you an answer. It gives you numbers. A missed grease fitting doesn't send an error code. There's no warning light, no noise, nothing that tells you the joint is running dry. What happens instead is a season of normal use and then a repair bill for a loader arm pivot or a steering linkage that wore down quietly while everything looked fine. The grease gun is the only tool in this entire list where the cost of skipping it is invisible until it isn't. A mid-sized tractor carries anywhere from 20 to 50 plus Zerk fittings, pivot joints on the loader bucket, steering rods, the PTO shaft, implement hitches. Add a trailer and a mower deck and you're past 60. A manual pistol grip grease gun, the standard from Lincoln or Alamite, works. The problem isn't function. The problem is that at fitting number 38, with a hand that's been squeezing a stiff handle since fitting number 1, the temptation to skip the awkward ones grows. Those are the ones that matter most, because they're the ones nobody reaches easily. The Milwaukee M12 cordless grease gun pushes up to 8,000 pounds per square inch and runs through up to 7 cartridges on a single charge. That pressure matters beyond convenience. A partially clogged or corroded Zerk that won't accept grease from a manual gun, where you physically can't generate enough pressure, will sometimes clear under 8,000 pounds per square inch. Not always, but sometimes that's the difference between a functioning fitting and a Zerk that needs to be drilled out and replaced. The battery compatibility question is real, though. If the farm is already running Milwaukee M18 or DeWalt, the M12 platform means a separate battery and a separate charger, which is either a minor inconvenience or an operational reason to reconsider. True temper wheelbarrows show up on every homestead recommendation list. What those lists usually don't distinguish is which generation. The steel tray models from the 1970s and 80s still turn up in barns in active use. They were built with heavier gauge steel and tighter weld tolerances. The current production line is functional, but thinner steel at the tray and weld seams that begin cracking under repeated loads of wet concrete, gravel, or manure after 2 or 3 hard seasons. True Temper does sell the steel tray as a separate replacement part now, which means a broken tray doesn't require a new wheelbarrow, but it does require the frame to have survived. The pneumatic versus flat-free tire question has a real answer and no universal winner. Pneumatic rolls better on uneven ground and cushions the load. It also goes flat, usually when the wheelbarrow is loaded. Flat-free polyurethane never punctures, but it's harder to push on soft ground and transmits every rut directly into your arms and wrists. The right answer depends entirely on what surface the wheelbarrow actually runs on, and that's a detail most product pages skip. Gorilla carts dominate online search results for dump carts, and the reviews trend positive. Good capacity, functional dump bed, reasonable price for the size. What the reviews tend not to mention is where the failures concentrate. The axle weld joints, where the axle meets the frame, crack under repeated loads above 400 pounds, especially on rough ground or hard starts. Documented cases include axle weld failure arriving new in box, confirmed across multiple orders from the same listing. The pneumatic tires deflate inconsistently, sometimes before the first load, and the polymer tray, left outdoors year-round, becomes brittle under UV degradation within 5 to 7 seasons. Not a structural failure, but a predictable end of life that a steel tray doesn't have. For bulk, lightweight material, mulch, straw, dry leaves, the dump cart makes real sense. For gravel, wet manure, or anything with concentrated point load and impact, a steel tray wheelbarrow outlasts it by a wide margin. Razorback and True Temper sit next to each other in the farm store aisle. The price difference is around $10 to $15. They look nearly identical at a glance. They're made by the same company, Ames True Temper. And that's exactly why the difference matters, and exactly why most buyers miss it. Razorback is the professional line, 14-gauge forged steel blade, a super socket collar with 2 rivets extending further up the handle junction, and a power step platform across the blade shoulder for safe foot pressure. True Temper is the consumer line, thinner steel, no super socket, single rivet or direct socket without reinforcement. The junction between handle and blade is the failure point on every shovel under load. On the Razorback, that junction is engineered. On the True Temper, it's adequate until you're driving a spade into clay hardpan or levering a root and the handle takes the full force sideways. The handle material choice has a different logic than most guides acknowledge. A fiberglass handle is lighter and doesn't rot. A wooden ash handle is heavier and can absorb moisture. But the field argument for wood is simple. When it breaks, you replace the handle. Hardware store, 20 minutes, same head. When a fiberglass handle cracks or splinters at the socket, which it does, usually at the ferrule under a hard lateral load, the tool is done. That's not a flaw in fiberglass. It's a repair equation with only one outcome. The square point shovel is a separate purchase, not a variation. A round point cuts into ground. A flat blade doesn't. It scrapes, collects, and transfers material from hard surfaces. Stall cleaning, spreading grain, moving sawdust or silage off a concrete floor, the flat geometry does that work efficiently in a way a round point blade can't match. Razorback makes the square point in the same heavy gauge tempered steel, US made, and the same handle argument applies. If there's livestock, horses, cattle, pigs, chickens, the manure fork or bedding fork becomes a daily use tool, not a seasonal one. The construction difference that determines how long it lasts is straightforward. Forged tines versus welded tines. Welded tines are lighter and cheaper to manufacture. They hold up fine in loose, dry bedding. The moment someone uses a welded tine fork to break apart frozen manure in January or jams it into compacted straw to get leverage, the weld at the base of the tine is exactly where it separates. Forged tines bend under that same abuse. They don't snap. Bent can be straightened. Snapped means a new fork, midwinter, mid-stall. Tine count isn't cosmetic. A 4 or 5 tine manure fork has wide gaps designed to pass loose material and retain solids, correct for wet manure and heavy bedding. A 10+ tine silage fork has narrow gaps for dry, light material like sawdust or fine mulch. Using a 4-tine fork for dry sawdust means half the material falls through on every scoop. Matching the fork to the actual material cuts the time in half. The bow rake, Ames 16-tine double head, has one documented failure pattern. The head leaves the handle, not slowly. The weld or wedge joint at the collar gives under lateral stress on hard ground, and the head rotates or detaches mid-stroke. Ames has replaced rakes 7 years after purchase with no argument, but the condition is the same as every other lifetime warranty. Contact support, send a photo, wait. The handle is a standard ash replacement fit for a 16-inch head, which means the head, if it survives intact, gets a second life. The joint doesn't always survive intact. The first time a T-post stops at 8 inches because it hits stone, the next purchase becomes obvious. Not next season, next week. A digging bar or San Angelo bar doesn't appear on most beginner farm tool lists, and that's exactly why it ends up being the first unplanned buy after the first fencing project hits rocky ground. A standard San Angelo bar from Trooper or Bully Tools runs 5 to 6 feet and weighs between 16 and 25 pounds. It doesn't cut or dig in the conventional sense. It breaks. Stone layers, old root masses, compacted caliche, frozen topsoil, the remnants of a concrete post base from 20 years ago. The weight is the mechanism. You lift it and drop it repeatedly into the same point until the obstruction fractures or loosens enough for the shovel or the post digger to continue. There is no ergonomic version of this tool. It is a heavy steel bar, and it works because it's heavy. The physical risk is specific. A bar that deflects off a buried rock at an angle doesn't give much warning. Without a firm two-hand grip and a clear stance, that deflection goes into a shin, a foot, or a knee. This isn't a tool that punishes carelessness slowly. It does it immediately. The post hole digger, from Razorback or Ames, is the most position-dependent tool in the group. The classic clamshell design, two hinged steel blades that open to bite and close to retain, works well in loose to medium soil. Clay is the problem. Wet clay doesn't release from the blades when you open the handles above ground. Every third stroke becomes a cleaning stroke, scraping material off the blade faces by hand before the next bite. Fiberglass handles reduce weight and improve balance slightly. They don't change the soil. Rock inclusions stop the process entirely. A post hole digger has no mechanism for cutting or fragmenting stone. It simply stops and waits for the digging bar to go first. The sequence that most new fence builders learn the hard way. Drive the post to check for stone first, then locate the hole, then dig. Discovering a boulder at 18 inches after 20 minutes of digging is a different problem from discovering it before you started. For 10 to 15 holes in cooperative soil, the hand digger is a legitimate tool. For 50 or more holes or any length of run through rocky or clay-heavy ground, it becomes a test of endurance rather than a practical method. A tractor auger attachment or a rented gas-powered one-man auger changes the math entirely, not in speed alone, but in what's physically possible without 2 days of recovery. The T-post driver from Tartar or Spico is a steel tube, closed at the top, open at the bottom, dropped repeatedly over the post under its own weight. A standard driver runs between 15 and 35 pounds. The weight drives the post. The operator's shoulders pay for it. 10 posts in medium soil. Manageable. 50 posts in a day. A legitimate physical project, not a casual afternoon. At the 200 post mark, which is a normal perimeter fence on a small property, the accumulated fatigue in the shoulders and forearms is the actual limiting factor, not the ground. A heavier driver, 25 to 35 pounds, needs fewer strikes per post but exhausts the operator faster. A lighter driver, 15 to 20 pounds, demands more strikes but distributes the load. In hard ground, the heavy driver is the only practical choice. In softer soil with a long run of posts, the lighter driver finishes the day without injury. The geometry problem that most product descriptions omit. A 6 to 8 foot T-post, driven to proper depth, puts its top above a standing person's head during the final strikes. On flat open ground with no elevation, the last few inches either don't get driven or get driven at an angle. The working solution on most farms, standing in a truck bed, on a trailer gate, or on a stepladder next to the post, is a field adaptation that predates any manufacturer's instruction sheet. Fence pliers are one of the rare cases in this list where there's a clear best option for a specific job. The Channellock 85 shows up on farm forums consistently, across years of threads, across different types of operations. The reason isn't branding loyalty, it's that the tool actually combines 4 functions that get used in the same 20-minute stretch of fence work: a hammer face for driving staples, a wire cutter, a staple puller, and a wire gripper for tensioning. Carrying 4 separate tools to do fence repair is how things get left behind in the field. One tool that does all 4 means it either comes back with you or it doesn't. The cutting edge is where cheap fence pliers fail visibly and fast. Galvanized wire is hard on soft steel. A no-name fence plier with an unhardened cutting edge starts deforming the wire instead of cutting it after the first serious session. Channellock holds the edge longer. Knipex, if you're comparing against a straight plier benchmark, shows sharper initial geometry and less wire deformation per cut. But Knipex doesn't make a dedicated fence plier. For the specific tool, Channellock 85 is the practical answer. Bolt cutters on a farm aren't emergency equipment. Old fence sections, rusted chain, lock hasps where the key is gone, baling wire that's been wrapped around a post for a decade. Bolt cutters come out regularly. The size question matters practically. A 14-inch cutter handles light wire and thin metal efficiently and fits in a tool bag. A 24 to 36-inch cutter is for thick chain and hardened rod, but it's unwieldy for daily use cuts. Most farms need both, or at minimum, a mid-range 24-inch that handles the majority of tasks without being too large to manage one-handed. The failure mode of cheap bolt cutters is specific. Cutting edges made from soft steel deform on hardened wire or case-hardened chain after a dozen cuts. The blades stop cutting cleanly and start crushing and bending the material instead. Knipex uses precision ground, hardened edges that hold geometry through extended use. H.K. Porter is the American equivalent, a manufacturer with decades of documented field use in agricultural and industrial settings. Both cost significantly more than hardware store alternatives. Both cut what they're rated to cut without deforming, which is the entire point of the tool. The come-along or hand puller, Mosdam or Wyeth Scott, is the tool that replaces a small crane for tasks where a crane is excessive and hands aren't enough. Tensioning a wire fence run, pulling a stuck piece of equipment, realigning a gate frame, drawing a timber into position. 1-ton and 2-ton capacities cover most small farm needs. The ratchet mechanism is the mechanical risk point. Under a wet or corroded cable or at the edge of the rated load, the pawl can slip or lock in tension. Releasing a come-along that's locked under load requires controlled, careful reverse operation. Rushing it is how the cable becomes a hazard. The anchor point is a separate problem that the tool itself can't solve. A 2-ton come-along attached to a fence post, a thin tree, or an underrated hitch ring doesn't pull 2 tons. It pulls until the anchor fails, which happens faster and more violently than the mechanism failing. Most field incidents with come-alongs trace back to anchor selection, not to the tool. A chainsaw is technically not a hand tool. It's also non-negotiable on a working farm in most of the U.S. Storm cleanup, firewood, fence line clearing, post cutting, limb removal. Stihl and Husqvarna divide the serious end of this market, and the actual performance difference between equivalent models from both brands is smaller than their respective communities believe. Stihl has stronger low-end torque and a distribution model that keeps it out of Amazon and big box retail intentionally, dealer only, which means a service center comes with the purchase. Husqvarna runs a higher chain speed and a more fuel-efficient cycle with less vibration at extended use. The practical question isn't which brand. It's which brand has a dealer within a reasonable distance. A saw that needs a carburetor rebuild or a new bar sprocket during cutting season is useless without a service source. Stihl's dealer network is the product as much as the saw. What nobody mentions to first-time chainsaw owners is that chain sharpness determines everything: efficiency, safety, and heat buildup. A dull chain requires more force, generates more heat in the bar, and dramatically increases the risk of kickback. Most new owners don't know when to sharpen, don't own a round file and guide, and start buying replacement chains instead. A sharp chain on a mid-range saw outcuts a dull chain on a professional one. That's not a metaphor. That's the actual operating condition most farms run in, and fixing it costs $4.15.